Hi, my name is Guan Wang, and today I'm talking about my final project, which is deploying the efficient machine learning model for the garbage classification on the Raspberry Pi. We can often see that in public areas such as shopping malls, restaurants, and a stadium, a large amount of garbage is generated due to the large flow of people. A large amount of harmful and non-recyclable garbage pollutes and damage the environment greatly. The implementation of garbage sorting can effectively reduce the cost of garbage disposal and realize the recycling of some resources. The garbage sorting model, with the help of machine learning, is an attempt to create a new model of garbage sorting. So the sorting equipment breaks the traditional recycling method, which reduces people's thinking time spent on garbage sorting and allows people to classify garbage more easily. By install the camera on the trash can, which can collect the images, transmit and transfer those images to the Raspberry Pi, and then classify the image. Finally, shows people what the garbage is. And the transfer learning of the mobile net and the fusion judgment of the sensor are used to realize the garbage sorting. So we can see the related work of the models. There are three models. The first one is mobile net. Mobile net introduces depth-wise separable convolutions to reduce competition, which is suitable for the embedded platform. However, the file size and the inference time shows that the model is still too large, and there is a room for the optimization for resource-constrained devices such as the Raspberry Pi. The second model is mobile net v2. So this model has a similar than the mobile net. The inference time is still significantly longer, which indicating the optimization is not fully adapted to the garbage classification task for my project. The last one is a mobile net with 3 small. So this one adding the ECE attention and this apply for the channel attention significantly reduce the file size and minimize the inference time, but this one has a terrible accuracy for the trash classification. Now I'm talking about the technical challenges. So the first one is the data variety and imbalanced data variety. So for the imbalanced data variety, it's trash images have large differences with the territories, but strong similarities between territories. So for example, the plastic bottom is confusion with the metal bottom in the real time. The second is the devices such as my Raspberry Pi has limited computing resources, memory, and power supply. So the next challenge is trade-off between model complexity and accuracy. So the high complexity model have the high accuracy, but which are not suitable for deployment on constrained hardware such as my Raspberry Pi. So you can see the limited computing resources for the Raspberry Pi. Check the size comparison between the Raspberry Pi 4B and the NVIDIA GPU. The Raspberry Pi, which is much smaller than traditional GPU, and you can see the uh, number of cores of the Raspberry Pi only got the quad core, and the traditional NVIDIA GPU like GTX Nano already got 128 NVIDIA CUDA cores. Now I design a mobile night model, but we need to deploy it to the Raspberry Pi 4B. So the first thing I should install the OpenVC on the Raspberry Pi and install the TensorFlow Lite to support the library 2. On the model prepare, I should do the conversion and quantization, so which can make sure my transfer learning model can use on my Raspberry Pi. By the way, so for the transfer files to the Raspberry Pi, I must use the ICP command to transfer the model to the Raspberry Pi. Now I'm talking about the method and the innovations on my project and my machine learning model. So I separate two parts. The first one is model optimization. The second one is the accuracy improvement method. So for the model optimization parts, I got 4 parts. The first part is pruning. So you can see my code on the right side. I remove the redundant parameters and reduce the model size. So the H5 file of the Novel 9 customers is only 1231 KB, which is suitable for running on my embedded devices like my Raspberry Pi. The next part is quantization. So you can see my code on the right side. Through post-training quantization, the model I can convert it to the int8 format, so which reduce the file size to only 157 KB, which will accelerating the interface process on my Raspberry Pi. The third part is depthful separable convolution. So you can see the code on the right side. I decompose the standard convolution into channel by channel convolution and point by point convolution, so which greatly reduce the computation complex and memory consumption. And the fourth one is data normalization and processing. So I normalize the pixel value to range of -1 to 1, which can reduce the training complexity and accelerate the model convergency. The accuracy. So the main method I use is IC block edit. IC attention mechanism arm to amplify the features of the important channels while suppress the unimportant channel through adapt learning of the channel weights. However, they log the consideration of the factors affecting the weights, which filter the surprise insignificant channel or the pixels. So I introduced the IC model in the middle stage of each block to ensure that features learning ability is improved while being lightweight. Then the next method I use is a inverted residual block. So combining the SE attention mechanism and the result connection, the model's ability to express features is enhanced without increasing computation complexity, and thereby improves the classification accuracy. So based on the now we can observe the evaluation results by the confusion matrix. For the first one, second one, and the last one, the model I designed, we they both similar, but for the third one, the mobile night with 3 small, we can see the confusion matrix, which means there has a lot of the image they didn't it didn't classification correctly. Now we can observe the evaluation results by the confusion matrix. For the first one, second one, and the last one, the model I designed, we they both similar, but for the third one, the mobile night with 3 small, we can see the confusion matrix, which means there has a lot of the image they didn't it didn't classification correctly. I will show you more tables on the next page. From this page we can see the table of the result more clearly. So we can see the last model I designed, the mobile night customized, the accuracy can approach to the 81%, which has only 157 KB for the TF light files. It's not accurate like the first one and the second one, but we can compare the size, which huge enhanced, and for the second one, the mobile night with 3i small, we can see it can't recognize the trash correctly. There has too simple other models already shows is trash. Only the V3 small model shows is metal, and another one is V3 small model shows the plastic bottom as a glass. So the conclusion is in the future, the model can be improved to explore more advanced attention localization, such as CBM and ECA, to further improve the feature learning and classification accuracy. And another additional enhancement probably can be started to improve the several features in instructions, and deploy a general model that can handle wider range of the image classification tasks while maintaining efficiency on embedded platform. Probably we can use more powerful embedded platform such as Jetson Nano or even Android phone. Another way is I can try different models such as the Euro 5. So I will show the demo of my project video.